Welcome to the channel, Infinite Exploit, where we learn and have fun. Let's get started and Brody, please don't forget to like, comment, and subscribe. Love you guys.
So in this video, I'm going to talk about if statements, and we'll also be using comparisons inside of our if statements. So previously, I just talked about basic if statements and Boolean variables. Depending on whatever the value of the Boolean variable, it does certain things. Now we're going to compare different values. I can compare numbers, I can compare strings. So I can do a couple things with this. So it's pretty cool. So it's going to give you a quick example here. So what I'm going to do is I'm going to create a Python function. I'm going to have it take 3 parameters and input, and it's going to pick out the biggest number. All right, so I'm going to do def max num, and inside of these parentheses, I'm going to specify 3 numbers. So I wanted to say num1, num2, num3, and don't forget the colons. Now it will return the largest of the 3. So in order to determine which one is the largest, we got to use an if statement. So I'll specify condition. So if, now we can compare these different numbers. So I can say if num1 is greater than or equal to the num2, and if num1 is greater than or equal to num3. Now we're going to end up with a true or false, right? It's a Boolean value. It's either true or false. Same thing with this side. So I'm putting a true or false by using a comparison. So this is a comparison operator, okay? We're saying greater than or equal to in this case. So it is true. So I can return num1, and I can do else if num2, num1, and num2 is greater than or equal to num3. This is going to be a true or false value as well. So I can return num2. So if all is true, it'll return num2. So we can return num3, and I can print max num, and I can do 5, 5, 6, 7. All right, and let's run. So 7, right? It doesn't matter where it is. I could change this to 500, right? We can compare strings as well. So I can make this a cat, and I can make this is a comparison operator. So this is greater than or equal to, right? But this is checking to see if this is equal to that. We can do this. This is not equal to. We have greater than, less than, greater than or equal to. So we got a lot of different we have a lot of different comparison operators. So in this video, we're going to talk about using dictionaries in Python. Now, the dictionary is a special structure in Python that allows us to create a dictionary with a key value pair. So we can refer to a piece of information by its key. So in a dictionary, you have a word and a definition associated with it. Now, the word will be the key, and then the value will be the definition. So I'm going to give you an example here. So I'm going to create a program that's going to convert a 3-digit month into a full month. So for example, if I want to do AUG to August, or DEC to December. All right, so I want to give it a name. So I'm going to call this month converter. So we want to do curly bracket, right? So inside of a dictionary, we can define those key value pairs, and I can give it a corresponding value. So we're going to give those 3-digit month names into full. So if I want to do AUG, I could do August. I could do December. Now we need a comma after these. Okay. This will be the key. This will be the value. All of these have to be unique. It's going to give us an error if I have the same right. All right. So give a quick example here, and we'll do Jan. Do January. All right. So this is like the basic of creating a dictionary. Now we can access them inside of this dictionary. Only thing I have to do is I can print. I can I can so I can specify this dictionary. Now I can also do an open and close square bracket, and I can do AUG, and it'll give me the full name. All right. So if I do, we'll get August. So I can refer to the key and then go in a dictionary and then give me the full. I also can do a get function, right? So if I want to put, if I get an invalid key, it'll say none, right? Now I could pass in a default, right? And I could say invalid. That way to say invalid, right? Now the keys don't have to be strings. So I could say 0, I could say 2, I could say 3, as long as they're unique, okay? All right. So now we're gonna go over while loops. And Python, it's a structure that allows us to loop through a block of code multiple times, okay? And I could put that code inside. I can, if it's true or false, depending on the condition, they can go through those iterations. So let me give you an example. First thing I want to do is I want to create a variable, and I'm going to use an integer. I'm going to do I equals to 1, and I'm going to specify a condition. I'm going to say while, and this will be the condition. I'm going to keep looping through this as long as it's true. So I is less than or equal to 10. Anything that's in this indentation is going to be in the while loop. So I'm going to say print I. So I'm going to say I is equal to I plus 1. And we can do a shorthand as well, plus equal 1. And that's going to be the same thing. It's our while loop. So defining this variable, I'm going to keep looping through it as long as this is true, and as long as this is true. And I'm going to print this is finished. So let's go. All right, we're printing out every time it goes through that loop. It's going to check this condition before it does anything else. Is 1 less than or equal to 10? That's true. So it's going to loop through that code multiple times, and it's going to add 1 to it. So it's going to go to 2, then it's go to 3, then it go to 4, 5. So it loops through, and it go back to the top and check it again. And once it gets to 10, it's going to print this is finished. and it's done with that loop. So that is how it iterates through this. So in this video, we're going to talk about for loops in Python. It's a special type of loop that'll let us loop over a collection of items. So we can go through arrays or letters inside of a string or a series of number. So it has a specific purpose. So I'm going to give you a couple examples. We're going to see why they're important. So in the Python file, all right, so we'll create it with for, and I want to specify a variable. It's going to represent a different value every time it goes through this for loop. Now, it's going to go through every iteration of the for loop, and each time, more than likely, have a different value. So I'm going to say in game, in Mortal Kombat, I'm going to say no, every word. We can do, I could print out word. So, so it's, it's pretty much, it's printing out each letter and it changes. Okay. So it went through this entire string. So what if I do an array up here? I'm gonna call it games and I'll call it Mario. I can spell. So I want to say for game and Sonic. I could print game. Clear this. So I can also do it an index and range. It's gonna print out every number except for 10, right? So if I do 20, it'll print out everything except for 19. Okay, it's a range. I can have it loop through this array as well, and I can pass in the length of the array as well. So I want to get the length of this, how many elements are in this. I can actually do len. It's going to spit out 3, right? I could do, and I could type games. And now I'm doing it with a range. So same thing. So 0, 1, 2. Okay, right. So that's a way we can print out those elements in that array. We can loop through any collection that we have. It can be a string, integers. That's like the basic of for loops. I want to show you one more example. So what if I do a range up to 6? So what if I want to do if index is equal to 0? I can do print first one, and I can do else second, right? All right, so I got it. Let's see. So I got an error here. It should be indented close to this line right here. Not sure why it's not. All right. Yeah. Yeah. All right. So I'm gonna also go over a exponent function. It's gonna allow us to take a number and raise it to a specific power. So if I go print and I do 5, 2 multiplication signs, and I can do 5, this is like 5 to the 5 power, right? It's easy to do exponents, right? I can use a for loop that'll do this. All right. So let's create a function. So we say def, and I'm gonna call it raise power. I'm gonna call it the base number, and I'm gonna raise it to the power number. We need to write some code inside of this function. We don't know the value of this. We don't know if we're trying to square it or cube it. So we don't know if we're cubing it. So I could return it, if I do base num time base num. So let me do this. We're going to do result 1. I'm going to do 4 index and range. This will range us through a collection of numbers. So I want to multiply the base num by itself as much as the power num specified. So if power num is 2, it'll loop through it twice. If it's 3, 3 times, 4 times, etc. So result is equal to result times base num. So it's stored in this result variable here. So if we're squaring a number, it's basically like base num times base num. So that's what this for loop is doing for us. I'm going to return the result, and I'm going to call it. And let's do 5 to the 7. Let's see what it gives me. All right, 8 to the 7. Go crazy. So the base number is getting raised to the power number. So result is going to store the actual result. So it's gonna range up to the power number. Okay, this is a power function. This is like the internal workings. So now, well, I'm gonna go over a couple things. I'm gonna show you two-dimensional list. I'm gonna call it number grid. Now, if we're creating a list, I can put a lot of elements in here. I can make everything in here a list as well. So I create another array with an open and closed square bracket, and I do 2, 4, 6, 8. And I do another item, and I do 3, 7, 9, 11. And we have these elements, and each one is a list itself. So 12, 13, 14, 15. And I'll tell you how we can access this. I can go print, and in here, I want to put the index of the row I want to access. So for example, this would be row 0, row 1, row 2, or 3. This would be column 1, 2, 3. All right. So if I go 0, 0, it prints out 2. So that's how we access elements inside the 2D list. So I'm gonna show you now. a nested for loop. So that's a for loop inside of a for loop. So I'm going to show you how to parse through this 2D list. So I'm going to say for a row and number. I'm saying that because of these are kind of like rows. So for each element inside of here, I can print. Can't forget my colons. So if I do for a column and row, it'll give me the individual column. So it's an indentation. Let's see. And that's the thing when you're debugging code. I like a lot of times it tells you what your error is, so you'll know what it. That's what the great thing about using the IDE instead of typing your Python code in Notepad, because it'll be hard to determine where the error is at sometimes. We're going to include it, and I'm saving this every time like this. I could do Control S, but I want to just remind you guys that when you're updating the code, you want to save it, because when you rerun it without saving it, it's going to run your previous code that you have there. Okay. Now, another thing I want to go over with you about comments and Python. So, I'm gonna tell you how we can use a comment. So, I'm gonna say what are comments, but we can do we can write a line that's not going to get rendered by Python. It's going to just ignore it. So they're used for us, like people. So that way, other developers, they can see what you have in plain text, so you can understand the code. Or and basically, it's a hashtag, right? I could say this is a comment. So if I run the Python code, it's not gonna read it to the screen. So you can explain a line of code. You can write a note to self, and you can say this prints out a string. You know. Now, if you want to do multiple lines, you can use another hashtag. But it's another way you can actually do it as well. You can use a triple quotation mark. So, so if I say this is a comment, they recommend use the hashtag, but it's another way. So, so you might have a line of code that's making an error, and you can see if it's causing trouble. You can just comment it out. So you're not deleting the code from the file. You just comment it out, so that way Python is not executing that line of code. Now, we're going to also talk about catching errors in Python. So it might throw an error or exception. It may stop your program from running. But what we're going to do now is we're going to look out for errors, and we're going to have Python handle those. So, so I'm going to do number. I could say, please enter your number, and it'll, it'll print a number. So what if I do 5? It'll print 5, right? But what if I enter a letter? I didn't put in an integer and I put in text. So a lot of times you can have errors like this. Now, if we're doing a real live code, we don't want the code to break, so we can handle them. And it's called a try and accept block. So it can try out this if it's great, but if it doesn't, it'll account for that. Okay. So I'm gonna show you how we can use the try accept clause here. So I'm gonna do try, and let me indent here, indent here, and I'm gonna say accept, and I'm gonna say this is not valid. So if I do H, it just say this is not valid. It's to protect the program. You can't have invalid input trip it up. So we can do uh try this up. It'll catch any error, right? So what if I want to create a variable and I want to do 50 divided by 0. So this is gonna be invalid. It can't handle that, right? We can accept specific types of errors, right? It couldn't convert it. So I can do two different type of errors. So if I want to do, so I can also do, another exception as well. So I could say, so, and I can have this as a var. So I could say, so, if I say, you can print out the specific error that you did as well, right? So you can print out specific errors, and you don't want to accept everything. You want to catch specific errors. So now we're going to talk about reading from external files in Python. Now we might want to read from a text file or HTML file. We can use the Python read command, and we can store it outside of our Python file. So I'm going to show you the basics of that. So so for example, let's do a text file here. Let's just say Mike equals janitor, Tom teacher, Billy receptionist, and Jake is a doctor. What if I did that, right? And I save it as, let's just call it workers. So it's a text file, It's gonna list out all this. So what if I wanted to read this, right? So I can open it with the open command, and it's going to be a relative path to the file or just the file name. So I already have them in the same directory, which is desktop. So I can just do workers, put it in string, and I can open it in a couple different modes. So I'm gonna put R. That's read. I just want to read the information. I don't want to modify it. I don't want to change it. I just want to read it and see what's in the file. Another mode is W is write. I can change the file. And another one called A, and I can append. That means I can add information to the file. So I can do new information. And R plus, that's read and write. We're gonna do R. We're just gonna be reading from the file. So it just open the file and it's gonna read through it. Okay. So we want to usually store this inside of a variable. So I'm gonna call it workers file. So I'm gonna have everything in here in this variable. So I'm gonna do a close function. So I want to do, yeah, anytime we open, we want to close it. Okay. That's how we open and close files. So so there's a couple functions we can use in this workers file. So I'm going to do a print statement. So we could print out the entire contents. So it's possible. You want to make sure that it's possible to read. So if we do readable, this is to return a Boolean variable, and it tells us if it's readable. So it says true. So if I do W, right, it's going to go false because we can only write to it instead of read. All right. So if I do read, it'll spit out everything in that file. If I do read line, it's going to read individual lines in that code, right? So let me show you. hmm So let's see. All right, let's see what we got here. Let me see if it's here. All right, let me save it. All right, now it's printing out each one. Okay, we can. So we want to parse through information in the file to read it. Okay. You always want to make sure you close it when it's done. That's the basis of reading from files. Now, let's talk about writing and appending to files. So, if I have an external text file like this one, like the workers text file, I can write to it. So we can write new ones and we can append to it. So, it reads the information like I showed you previously. So it read all the contents to the screen, and I'll demonstrate it again as you see here. And it's pulling it from this text file that's in the same directory. What if I want to add another worker? So I can come over here to my Python. I want to append. So That means I'm adding text to the end of the file. I'm going to add some text. So what I'm going to do, I'm going to say workers file, right? And I'm going to do infinite, and I'm going to say YouTuber. As you see here, it's added. They added it there. It didn't go into the next line, right? So appending, you want to be careful because you might add something wrong to the file. So what if we wanted to add another worker? They got appended to the end of the new line. And you want to add a new line, you got to add some special lines. So for example, do Jackie, and I'm do subscriber. So in order to add it to a new line, I'm gonna do all right. And if I save it, and then let's clear here and rerun it, it'll be on a new line. You see here? So it's an escape character. Anytime you want to add exactly what you want to add. I can also overwrite a file. What if we just write a file? So since I'm using W instead of A, it's gonna it's gonna overwrite everything. Let's see. It's only this one. You can also use W to create a new file. So if I wanna do one, right, and I write it, it'll create another text file called workers one. That's it. Sometimes you want to create a new file. Sometimes you can do different extensions. You can do HTML if it's like a HTML. I can do paragraph tags. It's basically used to create web pages, and they usually have HTML. So open and close tags is usually what you use in HTML. Okay, so that's one way that you can write to a file, or you can append to other files, and it's tons of files you can read and write to. So now I want to talk to you about using modules and pip. So module is just some code that we can import that has useful functions and variables. I can import it and I can access those into the code that I'm working on currently. So I'll show you where you can find modules, and what I'll do in this video, we're going to talk about modules in Python, and modules are essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file such as this one here that has a bunch of useful functions or variables, instead of copying all of this code here and pasting it in here, I can actually import um, this program as a module. So essentially, this one is already using the module already, a RE module that stands for regular expressions, and that's just the search for patterns and strings. Um, so essentially, what this function does is it checks to see if the password is too short. If it is, it's going to ask you to add an uppercase or lowercase letter, a number, or special character to make sure that it is strong. It also checks for username. Make sure it has enough characters, and it'll let you know if it's valid. And it also has a variable here that's equal to the string test. Okay, so for example, what I would do is I can do import sec checks since that's the name of this. And Python is smart enough to know that it's going to be pulling all those variables and functions from this file. So if I want to do print sec checks, and I want to do, for example, if I want to do check username function, check underscore username, and if I run it, it's going to check. So if I do password, it'll say should at least have one number, and if I do username test, should at least be 5 characters long. So if I need to simulate, I can actually use um, these functions, and so that's how you'll use modules. So when I go to my web browser, I can go to the official Python docs, and depending on the version that you're using, I clicked on version 3. It's a huge list of different Python modules that you can use. So it's all this awesome code that you can use, and if it's certain functionality that you want to use, it's a it's it's a it's a big list. So so it'll tell you how to use it. It'll tell you how to import it. You can find a lot of third-party modules, everything. So more than likely, if you get good at looking for them and finding them, it's a it, it's a lot of times it'll be used in your program to make it easier for you. There's a lot of different files and modules that we have access to. So where are all these files stored, right? So I knew when I was using my sec checks, I knew exactly where it was. So where are all of these located? So you have external modules. They're stored in the same folder that we have Python stored in on a computer. Now we have those in an external library, and it'll be in a lib folder, and it's going to store all these external modules here. So so a lot of these external modules are stored in libraries. So it's going to be some built-in modules as well. So for example, if I go, let me go to an example of one. So like for doing port scanners and stuff like that, you can see. So it's a lot of useful modules here. Some of them are not going to be in a lib folder by default. I'm going to show you how to install those here in just a moment. All right, so now we're going to talk about installing external modules. So sometimes they're not going to be pre-configured. It's going to be some great modules, third-party modules that you can use. Um, Here's one of the ones I like. It's called Beautiful Soup, and it's used to pull data out of HTML and XML files. So first thing you want to do is you want to make sure you have pip installed. If you're using Windows, it'll be command prompt. You want to be in your terminal. This is command PowerShell, but you can be a command prompt or PowerShell. If you're on a Mac computer, you want to use terminal. So the first thing I want to see is do we have it installed by doing pip version? And yes, we have it installed. Now, what is pip? So pip is essentially a program. It calls pre-installed with Python 3. It's a packet manager. So it helps you uninstall, install packages and things like that. So if we wanted to install Beautiful Soup, we'll do pip install Beautiful Soup 4, and it's going to install those packages, right? And we'll be able to use those libraries that we just imported. When you install this, you can use import beautiful soup or beautiful soup 4. Yeah, it's beautiful soup. And when you install with pip, it'll be in this site packages folder. Everything you need. If you want to uninstall it, you'll do pip uninstall beautiful soup 4, and then you can specify yes. So that's all I wanted to go over with you there. But it's very, very helpful. A lot of times we're working with a lot of different types of data. We're dealing with strings, plain text, Boolean values. That's some of the main types of data. We also have structures like lists, we can store them, but not all information can be represented using strings, Booleans, integers. So think about things like your TV or phone or airplane. These things can't be covered with these data types. So we can use classes and objects. So we can create our own data type. So I can do a car data type. I can do a computer data type. And I can create a class for it. So it says, hey, here's another data type I can use. So we can define it. So classes are very useful. So they're pretty much used in every major language out there. So what if I'm writing a program and I want to represent a car? So I want to model a real world object like a car. So we don't have a car data type. So I can't represent it with a string or a number. So I can create a class. So I'm gonna show you how we can do that. So I'm gonna call it car.py. Car.py. So class will be car. So we can define a bunch of attributes about a car. So I can use strings, integers, and booleans to kind of map out what a car should be and what it should have. So I'm gonna map out an initialize function. So we'll do def 2 underscores, init, and then 2 more underscores, and open close parentheses. We want to type out self, and I want a colon after that. So inside of this initialize function, I can map out what attributes a car should have. Here is a car data type. So after self, we can start thinking about what values will represent a car inside our Python program. So I can do name. Every car should have a name. They're gonna have a model. It's gonna have a price, and let's do a boolean. And I'm gonna say is expensive, and it's gonna determine if it's expensive or not. All right. So I'm defining what a car is. All right. So this is the car data type. So if I'm representing a car inside my program, that's what I'll be doing. So I can assign some values here in this initialize function. It might not make sense right now, but it will make sense after we create our car object. So just know we have to do this. So I'm going to do self.name is equal to name. I'm going to do self.model is equal to model. Oh, autocomplete is going crazy right now. Self.price is going to be equal to price. And we'll do self dot is expensive, and this is going to be equal to is expensive. Okay, so then I got this car class defined. I can actually use it inside my other file. So I'm going to go in the app.py file. That's my main file. Uh, I'm going to, so in the car, we actually define, those attributes. That's a template for what a car is. So I can create a car and I can give it some information. That's called an object. So this car class here is going to define what it is. So, so it's not going to be just this template anymore. We're going to actually specify it. So I need to import that. So I'm going to do from car pie. This is from this file. Import car. Okay. So I'm going to say car one and car. And I want to give it a name, model, price, and is it expensive. I'm going to say Ferrari. We're going to say Spider. We're going to say 500,000. And I'm going to say true. So this is a car. Car one is a car object. Okay. So I'm going to save this. I'm going to save this. So let's see, print car one name. Hmm. Let's see what it does not like about this one. Let's see. Give it some space so that way I can see it a little better. So we got the commas. So we got the name, model, price. I'm not sure why it does not like this. Invalid syntax. Let's save it one more time. So let's do a space. That's what it was. It don't have a space there. Okay, and I save it. All right, let's see if it'll run now. Okay, yeah. So it can pull the name. It can pull price. So so this car is a name, model, price, and option of is it expensive. Okay. So I went ahead and imported it here from this file, and this is referring to the class, right? So if I wanted to do another one, let's say I do car two equals car, and I do Toyota, and I do Camry, and I do 30,000, and I do false, right? I can do this, and I can get the price of that one. So car two, and it gives me the price of that car. So I created a car data type. Now I can represent cars inside of my program. So let me explain this. So so when I pass these in, it's going to get passed into this init function. So when I pass in name, model, price, and expensive, it gets stored in here. I'm giving that car object all the information. And this means the object name is actual equal to the name that's passed in. So it's the car is throwing a name, model, price in it. So these are all values that I pass in. This is parameters. So I need to assign them to the attributes of the object. So the name of the car will be equal to the name that is passed in. the name of the car's model is equal to the model that we passed in, and the price is equal to the price that we passed in. So when I say self, it's actual referring to the object. I'm giving it all this information when I have this car one variable here. Now we have a car data type. Now I can represent a car inside of my program, and you can do this with anything. So we did car class and car object. I can model phones. I can model TVs, computers. I can give it certain attributes. We can model real world objects and create our own data types. So now I'm going to go over object. So now I'm going to talk about class functions in Python. So we can modify objects in the class. So over here, I have a car class. I gave it name, model, and price. So I gave the car all of this. So in this app.py, I created two cars. So the car one is Ferrari, Spider, and this is $500,000 car. And car two is the Toyota. So I can define a function here where all of my objects can access it. So what if we want to create a function if we want to see if the car is expensive or not? So I can define the function that say is expensive. So let's say if it's over $60,000, right? If the price is greater than or equal to 60,000, that's expensive to me. I don't know about you guys. We're gonna return true and else return false. So so if I do print is expensive, so let me make sure I have that specified right. So yeah, I have. All right, all right. Let's see. Hmm. Oh, okay. I see what's going on. Name, model, price. Hmm. So if sale price is greater than or equal to 60,000, return true, else return false. And it takes 4, but 5 were given. Let me say this. It only have four arguments given. Hmm. So yeah, 1, 2, 3. Hmm. Let's save this one as well, just to make sure. No errors there. Hmm. I'm not sure why it's not able to import this. Save it. All right. Okay. I see what's going on. I see what's going on. All right. I got some booleans here. Let me take these out. All right. Because right here, this corresponds to this. All right. Now let's go. Okay. So yeah, car two is not expensive. It's a Camry. That's not expensive. Now let's look at car one and see if that's expensive. Oh yes, that's expensive. That's a Ferrari Spider. So that's a pretty good example of what a class function should be doing. It's just giving us information about the class. So that's the basic of using function in classes. I just want to introduce you to the concepts of putting functions inside of a class. So 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 now we're going to talk about inheritance in Python. So this is where we can define a bunch of attributes and functions and things inside of a class. And we can create another class and we can inherit all those attributes. So I can have one class that have all the functionality of another class without having to physically write out the same methods or attributes. So if that's confusing, don't worry, I'll go ahead and show you here. So so I'm going ahead and let me create a class, another class here. We have this one. I'm gonna use this let's see. I'm gonna make this a little bit more simple, and I'm gonna call it the car self, and I'm gonna say print fast. I'm gonna do another function, and I'm gonna say the phone, and I'm gonna have it print it's slow, and I'm gonna have the animal, and I'll do it's hungry. So in here, I'm gonna call it class random. So what it can do, it can just verify if car is fast, phone slow, or animal's hungry. So that's pretty much what it does. Three functions. It's just saying whatever these items are doing. So let me go ahead and I'm lazy, so I don't want to change the name. So I'm gonna go ahead and I'm importing that car pie, and I'm gonna random. So if I do my car is equal to, I'm gonna have that random. So if I did, for example, so that's random class, I could do my car, the car, like that. So let's save it and let's see what it does. Hmm. Make sure both of these are saved because it's pulling from that file. All right. Let's say I'm fast. So that says I'm fast. What if I wanted to make another class to represent another phone or another type of car? What if I want to do another fast car or a slow car, right? I can do a new one and I can do class slow car. So what if this one can run all this, but let's just call it everything car because it can do everything that's in here. And in addition, it can do something else as well. So let's just say do def, and I'm gonna call it all of it. And it can print. This one can make everything. So this car can be a phone, an animal. It can just do everything. It can do all of this stuff. So let me create an app. Go to this app, and I'm gonna create an object. So from let's call this everything car. So I'm gonna save this as everything car.py. All right. So I can import that one now. It will be because everything car is the name of the file, right? And the class is named everything car, capital everything car. Okay. So that's important. So let me go ahead and make a object there. My everything car is equal. I could do my everything. Well, I can do, let's see, yep, I call that one, and then I could do thing car dot all of it. So I can do that dot all of it, right? And let's see what it does when we run it. Oh yeah, I didn't add anything else in that class. So what I want to do is I want to give it all of this functionality here. So I can copy this and I can save it here. All right. Now let's clear and rerun it. Let's see. It's saying it doesn't like phone. It says unindent. Yeah, it doesn't like the indentation there. Yeah. All right. So it should be good now. All right. So it does both basically, and it can do it all. So so it inherits this. So what I can do so it can inherit this is I can get rid of all of that, and I can actually put when I'm putting everything car. I can say the name of the class called random. So I can say so and from this car pie file. I want to use random. I want to use all of this that's in there. That's what it's saying. So I still can run this. So if I take this out and I save it, I still can specify that here, right? Even though that all of it is not there anymore, I can still specify it. See it? That's because I got this method from this, right? So I can override classes as well. So a Python interpreter is basically a little environment that we can use to execute Python commands. It's like this little sandbox environment. We can test out or try different commands. So the way we use it is we can open up command prompt. So in, in Mac, it's terminal. So you got to open that to use the Python interpreter. So this is a terminal right here already. So the terminal is an environment where we can interact with the environment without using a graphical user interface, which is this, where we can interact with graphics, where we can click around. And so we can write Python in there. So we're going to terminal and we type in Python 3, or it would do. So it's Python. So I can go ahead and just do Python. That means it's not added to the path variable when it gives me that. And I can add it to my environment variable. So it's just not in the path. So I could do regular Python. So it opens this up and it shows the version I'm running. So if I go, so this is an interpreter. So I can write Python code in here. So if I go print hello infinite, it say hello from infinite. I could do num1 equals 1, num2 equal 2, print num1 plus num2 and gives 3. I can also do functions in here as well. So I can use if statements, I can use functions, I can use while loops. So pretty much everything we can use inside this interpreter. We can test out. This is somewhere where you don't really want to write serious scripts. I don't recommend doing it here. It's not an intuitive environment. It's just for some quick tests. This is a perfect place to do it. You don't have to do much. Yeah, but if you're writing an actual program, you want to use a text editor. It's gonna be way more organized. So that's the basis of Python interpreter. It is awesome. A lot of people use it. So this is how you get out of it. Okay.